Section 7.2 Series. Part 1, Summation Notation. The sum of the terms in a sequence a sub n from n equals j to n equals p can be written like this right here. This says the sum from n equals j to p of a sub n equals a sub j plus a sub j plus 1 plus a sub j plus 2, etc., all the way up to a sub p. So we're starting with j, whatever that number is. It might be 1, it might be not something else, and we're going to go up until we get to p. The second one, where we have n equals j to infinity, that means we'll just keep adding. So we have sum from n equals j to infinity of a sub n equals a sub j plus a sub j plus 1 plus a sub j plus 2, etc. This symbol is the Greek capital letter sigma. The letter n we'll call the index, j is the lower limit, and p is the upper limit. So let's look at specific examples. We want to find the following sums. We have k equals 1 to 4 of k squared. What that means is we're going to start with k equals 1, so 1 squared, and then we're going to add. What do we have when k is 2? We have 2 squared, and then 3 squared, and then 4 squared. And we stop at the fourth term because this said to go from terms 1 to 4. So we did terms 1, 2, 3, and 4. Then we need to add all these together. So this is 1 plus 4 plus 9 plus 16. And if I add those, I get 25, 30. The next one, I have k equals 1 to n of 2k plus 1. So I'm going to start with 1. So I have 2 times 1 plus 1, which is 3. Then I'll use k equals 2. So 2 times 2 plus 1, which is 5. And then k equals 3 would be the next one. So 6 plus 1 is 7. And I'm going to keep adding, and I don't know what n is, so I don't know how far I need to add. So I'll use this plus dot 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 plus, and then I'll use n for k. Let's write this one in summation notation. I have 1 plus 8 plus 27 plus 64 plus 125. So I want the sum from k equals 1, 2, 1, 2, there are 5 terms here, 1, 2, 3, 4, 5. Then I need to know what the explicit formula is. If I look at this carefully, this is 1 cubed, this is 2 cubed, 3 cubed, 4 cubed, 5 cubed. So k cubed is the expression that I need. So this sum now in summation notation, the sum from k equals 1 to 5 of k cubed. Factorial of a positive integer n, denoted n with the exclamation point, we call that factorial. So n factorial is the product of all integers from 1 up to n. So n factorial is n times n minus 1 times n minus 2, dot, 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 3 times 2 times 1, all the way down to 1. By definition, 1 factorial equals 1 and 0 factorial equals 1. So we're defining the first term and the second term. If you think of this as a sequence, we're defining 0 factorial and 1 factorial, and then we can use this equation to find any other factorial. So let's determine the number represented by the factorials. 4 factorial would be 4 times 3 times 2 times 1, which is 24. If I want 6 factorial, that would be 6 times 5 times 4 times 3 times 2 times 1. Now notice we already did 4 times 3 times 2 times 1, that's 24. So now I just need to multiply 24 by 5 and by 6, and I would get 720. Now there is a button on your calculator somewhere for a factorial. So somewhere there's some exclamation point. It might be a second function. It might be under the probability menu. You can find it for your specific calculator. But if we wanted something like 29 factorial, that would take a while to do it without just that factorial button. So there is a factorial button somewhere on your calculator. Write the sum in summation notation. 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial plus 6 factorial plus 7 factorial. There are a couple different ways I could write this. I could write this as the sum from k equals 1 to 6, because there are 6 terms there, of k plus 1 factorial. So we're starting with 2, so I need to have, when I substitute 1 in for k, I need to get 2 factorial. When I substitute 2 in for k, I need to get 3 factorial. I could also, though, write this as the sum from k equals 2 to 7 of k factorial. Either of those works. The first one would give us 2 factorial plus 3 factorial, etc. But the second one would give us that same thing. So if I wanted to find the sum, I could just put all of this in the calculator with your factorial button, and you will get 5,912.